Now, let us see that problem, what I asked you to work out. See the slide, please. In a batch of 10 articles, 4 articles are defective. Yesterday we did the same problem. 6 articles are taken from the batch for inspection. How many articles are taken? 6 articles are taken. Totally, how many articles are there? 10 articles are there. If more than 2 articles in this batch are defective, what does it mean? If 6 articles are chosen, how many articles are chosen? 6 articles are chosen. Then how many articles are defective in the overall slot? 4 articles are defective. If 6 are chosen, in those 6, if 2 or more than 2, or if more than 2, not 2, if more than 2 articles in the batch are defective, then the whole batch is rejected. Then find the probability that the batch will be rejected. I discussed this yesterday also. Just I read the problem and explained you. Let us see how it can be done. And whatever the problem you take up in probability, you must first write the total number of outcomes. That is, P of probability of any event E is nothing but N of E upon N of S. So N of S, you know, it is nothing but the total number of outcomes. So first of all, you write that, please, always. N of S. The total number of outcomes are totally 10 articles are there. From 10 articles, 6 articles are chosen, which can be done in 10, say 6 different ways. So in this case now, N of S is nothing but 10 to 6. Now, to apply the classical definition on probability, our denominator is fixed to be 10 to 6. Now, we need N of E here. What should be N of E? N of E is nothing but 6 articles are chosen, and the restriction there is, if more than 2 articles are defective, then the entire consignment will be rejected. So we need the probability for the consignment to be rejected. So let us take the total number of defective articles. 4. 1, 2, 3, 4 are there. So in this one, 6 total articles are chosen from all the 10. And if more than 2 articles are defective, means it must be either 3 or 4. That is our favorable here in this case. If 3 articles are defective or 4 articles are defective, then the entire consignment will be rejected. So how many total number of, first of all, always understand, you have to fulfill the restriction given. Then that means always your first operation must be fulfilling the restriction. What is a restriction? So here totally 4 articles are defective. Among them, getting 3 defective will reject the consignment. So getting 4 defective also will reject the consignment. So getting 3 defective articles, getting 4 articles is our favorable outcomes now. So here totally 4 articles are defective. From 4 articles, how many should be defective to get the consignment rejected? Is it should be more than 2. More than 2 means it may be 3 or it may be 4 also. Understand please carefully. More than 2 to be defective means it may be 3, it may be 4. It will not be 5 because total number is only 4. Okay. Now, what we did, we have chosen 3 defective or 4 defective. Okay. What should be the remaining? But totally how many are taken? 6 are taken. From 6, how many are already taken? 3 are taken. From 6, already 3 are taken. How many to be taken? 3 to be taken. 3 to be taken. How many total are there? 10 are there. From 10, 4 are defective. So how many are non-defective? 6 are non-defective. 6 are non-defective. So the remaining should be chosen from from the non-defective items. Non-defective is 6. So 6, 4C3, 3 chosen, but 6 to be chosen. So this should be 6C3. Understand this carefully. It is 10C6. You can see the total number of outcomes. Now how this 10 is split? 4 plus 6. Why? 4 defective, 6 non-defective. 3 chosen from defective, 3 chosen from non-defective. This is one way of selection to get the consignment rejected. Okay, either this or. Either this happened or this may happen. That's what from the beginning itself I've been telling you. Or stands for plus. This plus, we have seen that it is nothing but union, addition theorem. So instead of union, you can write plus. Instead of plus, you can understand it as R plus or union or one and the same. So this may happen or this may happen. What is this? Choosing all defective articles. How many are chosen? Totally 6 are chosen. From 6, how many are already chosen? 4 are already chosen. How many are remaining? 2 are remaining. 2 are remaining. Those 2 are to be taken from the non-defective items. How many non-defective are there? 10 minus 4, 6 are there. So from 6, you have to choose 2, 6C2. So this operation and this operation, this is for AND. AND means multiplication. So if this happens or this happens, the entire consignment will be rejected. Understand that? So this is nothing but, if you simplify, 4C3 is nothing but 4C1. It is 4 into 6C3. As I've explained to you yesterday, don't write the factorial, but write the short form of it. 6 into, write 3 factors starting from 6, consecutive factors starting from 6. 6 into 5 into 4 upon 3 into 2, 6 getting cancelled. 5 into 4, it is nothing but 20. Plus 4C4 is 1, 6C2 is nothing but 6 into 5 upon 2, it is 15. So 80 plus 15, it is nothing but 95. 80 plus 15, it is nothing but 95. Therefore, your required probability is nothing but 95 upon 10C6. You can, instead of 10C6, remember, for the sake of simplification, you can write it as 10C4 also, because NCR is equal to NCS. These are the groups. These are the groups. There will be no internal arrangement. The order of things is not considered. So 10C6 is nothing but 10C8, 10 minus 6, 10C4. So it is 95 into 4 into 3 into 2 upon 10 into 9 into 8 into 7. If you simplify this, you'll be getting the final answer. Simplify that, you'll be getting the answer. Okay, so this is how you can approach. What is the difference between the previous problem and this problem? In the previous problem, you have only one restriction. Something, if you remember the yesterday's problem, there's only one restriction, but here it is split into 2. It is split into 2. That is why it requires either this, R stands for plus, and we have got it. This total number of outcomes in the denominator and the favorable outcomes in the numerator. So this is the solution for this problem. Let's go to another problem. It's an interesting problem, but you must be knowing the playing cards. 52 playing cards are there. I hope you all know the cards. You must know, because in the problems, the cards will be given, and you have 4 categories in the cards. Then the 4 categories are said to be 4 suits. 4 suits. This is spade, clubs, and diamond, and hearting. So these are the 4 different suits, and among them 26 are of red color and 26 are of black color, and each suit consists of 13 cards. So 13 into 4 is 52, and 13 cards you will have A's for A and A's for A, and the remaining will be 2 to 10, and next will be king, queen, jack, like that. Totally 13 cards in each suit. 13 into 4 becomes it is 52 cards. So you must know that first. If you don't know, please learn them, because while teaching this probability, generally some of the students, like at least 20 to 30% in the class of the students, they are not knowing how the cards will be, how the playing cards will be, but we don't have time to discuss the cards because the time is very less here. That is why you can understand that very easily if you take those set of cards and you see that if you don't know how the cards will be, what is their face value and how the number cards will be, and all these, you please go through that if you don't know. Now the problem is based on that only. Now consider the following 3 hands of 5 cards. 3 hands of 5 cards. That means each hand is having 5 cards dealt from an ordinary deck of 52 cards. Ordinary deck of 52 cards. Okay. What is H1 here? H1 is all 4 queens and a 2. All 4 queens and a 2. All 4 are queens and a 2. All 4 are queens mean how many queens will be there? You know, each suit consists of 1 queen. So all 4 queens case is only 1. Only 1. So the all 4 queens, spade king, spade queen, let me say, queen from the spade, queen from the heart-in, queen from the diamond, queen from the spade, heart-in, diamond and clubs. Only 4 cards will be there always. There is no other selection for this one. So this set for H1, are you looking at the problem? See the slide please carefully. H1 is all 4 queens, all 4 queens, only one way. So you can choose it only in one way, 1C1. And a 2. And a 2 means it's a number card. It's a number card. Each suit will have number 2. That means spade 2 you will have, heart-in 2 you will have, diamond 2 you will have, clubs 2 you will have, clubs 2 you will have. So how many 2s you will have? 4 2s you will have. From 4 2s you need only 1 2. A2 is given. A2. So 1 2 you need. So from all the 4 10s you can choose only 1. First operation, second operation, 1C1 into 4C1. 1C1 into 4C1. 1C1 is what? Consists of all the 4 cards. 4 are there, 4. And 4C1 is what? From 4 10s you are choosing only 1 10. So which first operation, second operation, which can be done in 4 different ways. H1 is nothing but 4. Similarly, H2 if you see, H2 if you see, it is the ace, king, queen, jack and 10 all in the same suit. All in the same suit. How many aces will be there? 4 aces will be there. How many kings will be there? 4 kings will be there. How many queens will be there? 4 queens will be there. How many jacks will be there? 4 jacks will be there. So they must be all taken from the same suit. Same suit. Okay. So same suit means this is, let me say this is one suit. Spade is one suit. Then what are they? Ace from spade. Next what? King from spade. Next what? Queen from spade. Next what? Jack from spade. Okay, all in the same suit, and 10 all in the same suit, and 10 also can be taken. Like 10 means, let me say 10 spade. For your understanding, I am taking S as a spade. This is from spade suit. Similarly, you will have A from H, K from H, Q from H, J from H, and 10 from H. This is R10. I will do like this. This is one set. This is second set. What is the third set? A from diamond, king from diamond, and queen from diamond, and jack from diamond, and 10 from diamond. This is third set. And what should be the fourth set? A from clubs, king from clubs, and queen from clubs, jack from clubs, and 10 from clubs. How many are there totally now? How many sets you have got now? You can see that clearly. 1, 2, 3, 4. From 4, we need one such set is nothing but H2. So it is nothing but, you can understand, it is nothing but 4C1. It is also 4. This has got to be 4. This is also got to be 4. Now, what should be H3? You can understand that. That 10 of hearts, the 10 of hearts, how many 10s will be there in hearts? Only 1 is there. Only 1 is there. And the 10 of clubs, how many will be there? 10 of clubs, only 1 will be there. And 3 kings. 3 kings we need. How many kings will be there totally? Just now we discussed. How many kings will be there? Kings will be always, you can see this clearly. Spade king, heart king, diamond king, clubs king. How many kings will be there? 4 kings will be there in the set. How many kings we need in H3? We need 3 kings. We need 3 kings. So from 4 kings, we choose 3 kings. It can be done in how many different ways? 4C3 different ways. 4C3 different ways. What about the remaining? The 10 of hearts. Hearts, 10 will be only 1. So it can be chosen in 1C1 only, please. And the 10 of clubs. The 10 of clubs means for clubs only 110 will be there. It is also 1C1. So 4C3 into 1C1 into 1C1 is nothing but 4. This is 4 ways. This is 4 ways. And this is also 4 ways. You can see that clearly. Now, see the options. H1 is more likely than H2 or H3. H2 is more likely than H1 or H3. And H3 is more likely than H1 or H2. All the 3 are wrong because equal chances of getting, because it is 4, it is 4, it is 4. So last one, if you see the fourth option, all 3 hands, H1, H2 and H3 are equally likely. That is equal chances of occurrence for these events to occur. It's a beautiful problem. If you follow this carefully, if you work out these problems on your own, really you'll enjoy working out the problems. Okay, but before that, make sure of yourself that you know all these denominations, suits, face card, number card, and all this you must know. Okay.